For years, Proxima B was just a ghostly shadow orbiting the nearest star to our sun. Astronomers could measure its pull, make wild guesses about its size, even model its orbit, but no one had ever seen it until now. The James Webb Space Telescope has finally captured the clearest image of Proxima B in human history. Forget artist sketches or fuzzy pixels. This is a real planet with clear terrain, vivid colors, and clues that could change how we think about life out there. But what exactly did Webb uncover? And why are scientists already saying this image has changed their perception about space exploration? Stay with me, because the closer you look, the stranger it gets. The mystery of Proxima B. For decades, Proxima B was a puzzle made of half-finished pieces. We knew it was orbiting just over 4 light-years away, practically next door in space terms, and sitting in the habitable zone where water might exist. Beyond that, though, it's been all guesses. Older telescopes could only hint at its presence through subtle wobbles in its parent star's motion. Proxima B was, in every sense, invisible, and yet it has always captured our imaginations as a rocky, Earth-sized world orbiting its closest star. Now, the James Webb Space Telescope has blown that mystery wide open. The new image shows mind-blowing details of the planet. Think about patterns, contrasts, and features no one ever thought we'd see from this far away. And some of them are raising more questions than giving answers. The first glimpse. When the first processed image came through, mission scientists reportedly fell silent. What they saw wasn't some blurry smudge. It was a planet, clear as day. You could see the curve of its horizon, with areas of shadow and light. There were even faint textures on the surface that might be mountains or plains. Infrared overlays revealed thermal patterns across the planet's surface. They clearly showed smoother gradients, as if heat was somehow being shared across the globe. That could mean an atmosphere, possibly even weather. And then there were the patches that reflect starlight in a way that stands out. Could they be ice or clouds, or something we can't yet explain? Webb's instruments gave us a view we never dared to expect, and with it, a flood of new mysteries. Strange signs on the surface. As scientists examined the image in detail, they noticed features that didn't match earlier predictions. Across the planet's midsection, faint lines appeared like scars etched into its surface. These could be tectonic ridges, or the remains of ancient lava flows, suggesting there might be active volcanoes and lava streams underneath the surface of Proxima B. On the dark side, far from the red dwarf's glare, there were small, unusually bright points. Some believe they could be reflective ice deposits or dense cloud tops catching stray starlight. Others wonder if they're volcanic peaks, glowing faintly with trapped heat. Even more strange were wisps of semi-reflective material hovering over certain regions. These could be cloud systems moving through a thin but Earth-like atmosphere. If confirmed, this would mean Proxima B can circulate air, trap warmth, and maybe even sustain stable climates. One thing was clear. Proxima B wasn't the dead, frozen rock people had imagined for decades. It's full of complexity, maybe even something more. Could that be a sign of life? The atmosphere mystery. When Webb's instruments analyzed the planet's light, the results were surprising. It picked up chemical signatures, not just rock, but gases like carbon dioxide and maybe even water vapor. If true, this means Proxima B has an atmosphere capable of holding heat and maybe even shielding its surface from deadly radiation. And then came the real twist. The thermal maps showed smoother temperature transitions than anyone expected. For a planet likely locked to its star, one side in endless daylight and the other in eternal night, this was unusual. Something, perhaps winds, oceans, or even volcanic heat, was evening out the extremes. To scientists, that raised a question too big to ignore. Could this be the first evidence that Proxima B has the climate stability needed to host life? Hidden clues beneath the clouds. Beneath those wispy clouds, Webb's data revealed something even more intriguing. Patterns across Proxima B's surface that shouldn't be there. Long, banded features stretched across the midsection, almost like mountain ridges or ancient lava flows. If confirmed, these could be evidence of volcanic or tectonic activity, signs that this planet isn't geologically dead. Why does that matter? Because an active interior can recycle nutrients, build atmosphere, and create the complex chemical environments where life might begin. And if Proxima B truly has both an atmosphere and an active geology, it suddenly becomes one of the most promising candidates for alien life we've ever seen. The life equation. For decades, scientists have searched for the perfect balance, a planet in the right place with the right conditions at the right time. Now Proxima B is starting to tick far too many boxes to ignore. Early spectroscopic readings from Webb hint at traces of carbon dioxide and maybe even water vapor. If both are confirmed, it would mean this world has the raw ingredients for life as we know it. But here's the catch. Proxima B orbits a volatile red dwarf, a star known for violent solar flares. Yet somehow, this planet might be holding on to its atmosphere. That could mean magnetic shielding, active volcanic outgassing, or some unknown factor we've never seen before. And if that's true, then our nearest neighboring planet might not just be habitable, it could already have alien life. The flare factor alien life on Proxima B, if it exists, would live under a constant threat. Its host star, Proxima Centuri, is a red dwarf famous for unleashing powerful solar flares hundreds of times stronger than anything Earth experiences. These bursts of radiation can strip away atmospheres, scorch surfaces, and sterilize entire worlds in moments. Yet the new Webb data suggests Proxima B still has an atmosphere. That means it's either replenishing it faster than it's being destroyed, or it's protected by something extraordinary. Maybe a powerful magnetic field, maybe volcanic outgassing, or maybe something we've never encountered before. But if life has adapted to survive here, it would be unlike anything we've ever imagined. Life that thrives in the shadow of a dangerous star. Signs in the shadows. If Proxima B hides its most important secrets, they may be in the dark. The Webb telescope didn't just capture the sunlit face, it peered into the shadows. Here, on the planet's perpetual night side, it detected faint traces of heat and swirling patterns that could be moving clouds or pockets of warmer air drifting from the daylight zone. And here's where things get weirder. There are certain hotspots that shouldn't exist. They're warmer than the surrounding terrain, almost as if something beneath the surface is generating heat. Could it be volcanoes, or maybe underground oceans heating things up? What else could cause that kind of warmth? Whatever the answer, these mysterious signals have scientists buzzing, because in the darkness, life can hide. The first clues of life. When scientists began analyzing Webb's atmospheric data from Proxima B, one signal stopped them cold. The light passing through its thin layer of gases carried the fingerprints of chemicals we know well. They found a trace of methane, something that on Earth often comes from living things. No one's saying life yet, but it's got scientists talking. No one is ready to say life yet, but the possibility is on the table, and that alone changes everything. If confirmed, it would be the first time in human history we've seen evidence, real, physical evidence, of life beyond our planet. This isn't just a radio signal or some equation on a chalkboard. It's a planet that might actually have life based on chemical traces we're seeing. What happens if we're not alone? If this signal from Proxima B truly points to life, the world will never see the night sky the same way again. Governments will demand answers. Telescopes on Earth and in orbit will turn toward that single point of light, and ordinary people, billions of them, will look up with new questions. For some, it will be a moment of hope, proof we are not alone, that life can emerge in more than one corner of the universe. For others, it will spark caution or even fear. What would contact mean? Should we speak first or stay silent? History has shown that every time humanity learns something that's part of something bigger, our understanding of ourselves changes. This would be the biggest shift of all, and whether it leads to our greatest leap forward or our most careful step back, that choice will be ours. We are looking at a world that, for thousands of years, was nothing more than a point of light. Now, we see it as a real entity, a real place that exists in the dark, waiting for us to understand it and decide what kind of explorers we will be. It shows how much we want to understand the universe and keep pushing forward. It's what makes us human. Someday, a probe, or maybe a human, will stand where this image now takes us. They'll breathe the alien air, feel the crunch of alien soil, and look back across light years toward home. And when that moment comes, we'll remember this: the first time we truly saw Proxima B.